Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using KNIME. In this chapter we're going to look at yet another method of a decision tree, and this is called gradient boosting trees. So let's review here. Ensemble models combine multiple learning algorithms to improve the prediction performance for each algorithm versus each algorithm alone. And there are two main strategies we reviewed earlier in the introduction to this class. Those two strategies are bagging and boosting. Now, bootstrap aggregation, or bagging, is the ensemble technique that trains many iterations of a model on that single classifier using different partitions of the training data set. And then it then combines, it uses a combination of all of those prediction models to form the final prediction. My favorite example, I like to compare that to the Borg. There is no one leader, there's just a common collective. Now, in the last chapter, we used the KNIME random forest decision tree to implement that technique. In this chapter, we're going to be talking about boosting, though. Boosting is another ensemble method, and it works with weights, but unlike the decision tree where we use random forest, these weights occur in both phases. During the learning phase, the boosting procedure tries to train each new model by adjusting parameters for that model to handle the errors that have been passed through from the prior model. And then during the prediction phase, it provides a prediction based on the weighted combination of the models. And so let's take a look at this in a little more detail. So when we look at bagging, the random forest, the training data set was broken up into multiple random data sets. That would basically be resampling from your original sample, uniform distribution, and then all of the models were created in parallel. So that was the random forest. In boosting, instead, the training data set is going to be, we're going to pull a weighted sample that's going to develop a model. And then the output of that, those that it got wrong, will go into the next model and be weighted further, and so on. This is all done sequentially instead of in parallel. This is a chart I pulled off of one of the KNIME forums that is a good representation of the single decision tree which we went through, and then the random forest on the right, where you see there's just many trees and that they'll all weight together to vote on the proper solution. And then finally, the gradient boosting tree is each tree is done in singular form, where the first tree creates and then the errors pass down to the second tree and the third tree and the fourth tree, and so on. All right, let's go ahead and look at a gradient booster, because you're not going to see, frankly, a whole lot of difference here between the other forms of decision tree learners and predictors that we've created. In the gradient booster, I've done the same thing we've done before. I've done my split of the data, and in the gradient booster, I've chosen the target column, and I'm allowing it to use all of the columns that are currently in the data set. Now, I'm limiting the number of tree levels because this is boost 2.4. Just rule of thumb, I try to keep them from 2 to 6. Much more than that is starting to get to be quite a deep tree. So you might play around with different levels. From 2 to 6 would be somewhere in that area, and you might want to build a parameter optimization loop to try that. I'm going to train 100 models, and the learning rate basically represents the, think of it as the weight that any individual model can have over others. Generally, the 0.1 is going to be just an acceptable number for you. And then the predictor, of course, does the same thing. There's nothing to specify except that we're going to predict the confidence intervals are going to be added to the output, and that that's going to be the column name that comes out. So when I execute the score node, we still have the confusion matrix that we always have. And we still have the accuracy statistics, which we always have had. So the same thing. What I can see right here is on the case of the wins, which is what I'm usually interested, I've dropped now down back to 0.636, so about 64% ability to pick a win. So this model is actually not doing nearly as well as we did with our random forest. I think that was another 6 or 7% higher. So, but again, every data set's different. That's why we go through this exercise of trying different models to see which one works best with our data. Well, when we compare the results of our gradient boosted tree back to the results of random forest and C45 and CART, we're seeing gradient boosting actually didn't help in this particular data set. When I look at the two columns I'm always focusing in on are the sensitivity for the wins, and it's dropped all the way back down into the 64 range. And so this is not likely a solution I'm going to use on this particular data set. That completes this chapter of the class. Feel free to move on to the next chapter.